Hello everyone, here is our lesson number 2. So, to do this one, I'm gonna focus more on the paper that you have, and I'm gonna follow exactly point after point. Maybe that's gonna help you to know where we are exactly. But you need to have it in front of you while I'm talking. Alright, so we start now at the page 3 in the small 3 application. So for the graphs, you can read a lot of things. Each graph has a lot of information concerning its function. And that's what you have to learn and to understand how to read a graph, how to use it, what information is where. Because just by looking at a graph, there is a lot of things that you are supposed to know. For instance, the two easy ones that comes first in our lesson. First is the y-intercept. So the y-intercept means the position or the point where the line or the graph crosses the y-axis, y-intercept. So for instance, here I took exactly the same example as your paper. So you have your two axes and you have that straight line crossing here. The y-intercept is when the blue line crosses the y-axis. So here it's at this specific point. It crosses the y here. When a line crosses the y-axis, it has to be that on the x-axis it's a 0, because it's on the 0 point for x that you're crossing the y. So the interception, the y-intercept for this blue line is, the y-intercept is 0 for x and 3 for y. X has to be 0 and you just read the y value. Right. For the x-intercept, exactly the same, but on the x-axis. So that's when our graph crosses the x. To cross the x, you have to be on this specific line, which means that the y value is a 0. You are on the x line, you have 0 for y. So this x-intercept here has a specific x value, but has to have a 0 for y. And here you just read, it crosses at 2, so the x-intercept is the 2, 0. Easy. Y-intercept has a x equal to 0, x-intercept has a y equal to 0. And then you just solve the other one, because remember, a function has a correlation between the x and the y value. So if you know the x, you can find the y. If you know the y, you can find the x. Always. Alright, so that's our two first points from this. Now, third one. Two graphs intercept each other when they are equal. So if two graphs are equal on one specific point, that means they are on the same point and they intercept. Therefore, I can draw a second line on this graph. So I'm going to choose an easy one for the demonstration. Here, this y2 would be x. The y equals x. Easy graph, but it exists. Alright, so I can see clearly it intercepts once. Here, the two lines are on the same spot when they cross. So here on that specific intersection, I've got coordinates of this point. And this is where y1 is equal to y2. So if I can't read it on the graph, because I'm not sure exactly where is the point, I solve it with the calculation. So I just have to solve y1 equals to y2. Equation of y1 minus 3 over 2x plus 3. So I take the equation, and I know when it crosses, y2 is going to be equal to y2, and y2 has x for equation. Here I am. That's just solved. So all the x's on one side, numbers on the other side. Here I'm going to have 3 equal to 3 over 2 plus x, but I want to have it over 2, so it's going to be a 2 over 2 x. 3 equals to 5 over 2x. Take the fraction on the other side. 3 divided by 5 over 2 equals x. If I divide by a fraction, I can time by the inverse. So 3 times 2 over 5 equals x. And the x value here is 6 over 5. Can I simplify? No. Prime number 5, so that's my simplest fraction. So here it's going to cross. The blue line and the black line are going to meet for x equals 6 over 5. So just slightly above 1, which is more or less what I have on my drawing here. Alright, is that enough? Here I've got the x value. But that's not going to be enough, because I need the coordinates. So I need the y value as well. And here I'm lucky because that's very easy. I can substitute that x value in any of those two equations, because on this point they are equal. So I'm going to take the easy one. The easy one is y2, to calculate the y value corresponding to this x. So y2 is equal to 6 over 5. That's it. I've got nothing to do, no calculation, because I've got y equals x. If I put the x in this equation, I just need to do the calculation to find the y value. And here I've got x 6 over 5 and y 6 over 5. That is the intersection between those two graphs here. Sometimes, depending on what graph you're working with, you will have two intersections. So sometimes when you solve for x, you get two solutions, and when you have two x's, you must calculate the corresponding y for both. So you can get the intersection 1 and the intersection 2 with the two coordinates. Alright. So to remember here, two graphs are equal and intercept when the equations are equal. So you equal y2 and y1, solve for x, and get the coordinates. Alright? We only have two things left here, domain and range. Okay, so this is done. And now we're going to work with the domain and the range of this one. It's the same than the one you have on the page 4. Right? Yours is a lot neater, but that's the same graph. Okay. So what do we have here? The domain is the interval on the x-axis where the function exists. So for instance, for this blue line, the domain will be here, there. That's the domain. The range is the interval of the y-axis where the function exists. So here it's the same thing, but you look at the y-axis. Where does it exist? From here down. That's the range. Alright. So just the only thing you have to remember is domain on the x, range on the y. If you remember that, you just have to read your graph. So here, what does this mean? The domain. You see that dot here for this specific graph, they made a restriction that you can't go above that point. But normally in your exercises, you will have no restriction. But it can happen, so it's good to see it. So this point means nothing above that. But on the other side, you have an arrow. This arrow means it's going to carry on until infinity. So there is no restriction here. So on the x-axis, where does it start? Your graph starts existing on here. That's the beginning of the existence of your graph. And if you move to the right, here it exists, it has values everywhere. Here it's negative, but it has value. And here it goes down, but it still exists. Technically, this graph is going to carry on to infinity down there. So, the domain of this graph is an interval that starts from that -5 here. So it's written on the x-axis. X belongs to the interval from -5. It's a full dot, so that's including 5. Up to the right, there is no restriction. This graph is going to slowly but surely go up to infinity. So it's going to go to positive infinity, and we never include the infinity. So that's the domain. Now the range on the y, same thing. We're now focusing on this axis. Where do you have some blue line on this y-axis? So the range here. You read the y, so you answer the range with a y belong to. What's the maximum value on the y? The blue line stops at 5, so above that you don't have any axis or any graph. So the maximum is 5, and it goes down to infinity. There you're going to have blue line everywhere. So, remember, when you write an interval, the smallest value to the left and the higher value to the right. So we start with -infinity, and I think I didn't do that on the paper. I didn't. But okay, it's fine. It means the same, it's just a convention. So -infinity is the minimum, and then up to +5, and +5 is included because it's a full dot. So here y belong to -infinity up to 5. Correct what I wrote on the paper. This is better. From -infinity to 5. Alright. So domain on x, range on y. And you take from up to. Sometimes, if you have a gap, you can have two intervals. It can be from 5 up to 2, union from 1 up to positive infinity. It can happen. It can be only one interval. It can as well be complete real numbers from -infinity to positive infinity. You just check where are your restrictions. All right. I think that's all. That's all for today. So, you have now the practice exercise. So here, the whole exercise, question 1 to 7, and that's for Friday. Good luck. Bye-bye.